Hello there, welcome to my channel. Today we're going to be solving a really nice exponential equation where we have x minus 2 to the power of x squared plus 5x plus 6 equals 1. Now obviously we want to solve for x values, but in order to do that we need to ask ourselves when an exponent equals 1. So let's say that we have something like a to the power of b equals 1. In this case, we're going to have three cases for the values of a and b. So one case is that a equals 1 and b can be any real number because 1 to the power of anything gives us 1. The other case is that a equals -1 and b should be even because -1 to the power of something even gives us 1. And finally, the last case is that a should be anything other than 0 and b should be 0 because anything other than 0 to the power of 0 gives us 1. So let's go ahead and use these three cases to solve for x. So in the first case, we want the base to be 1. So we want x minus 2 to be 1, and that means that x should equal 3. This is the first case. In the second case, we want x minus 2 to be -1, and we want the power, which is x squared plus 5x plus 6, to be even, right? So from this, we're going to get x equals 1. And notice that we want x squared plus 5x plus 6 to be even, right? We want this to be even. And for x equals 1, this is going to be 12, because 1 plus 5 plus 6 is 12. So if x equals 1, our power is 12, and 12 is even. So that means that x equals 1 is a valid solution as well. In the third case, we want the base to be anything other than 0. So that means that x is not equal to 2, right? It is forbidden for x to be 2. But at the same time, we want the power, which is x squared plus 5x plus 6, to be 0. This is a quadratic equation, so we can solve this using different methods. I'm going to go ahead and use the factoring method, and I'm going to factor the left-hand side into x plus 2 times x plus 3, right? That means that x either equals -2 or it is equal to -3. And none of these two values is equal to 2. That means that both of them are valid solutions, right? So we have 1, 2, 3, and 4 valid solutions for our equation. And this brings us to the end of this video. Thank you for watching this. If you enjoyed watching this, hit the subscribe button and hit the like button, and I'll see you later.